Alright, in section 2.4, we're going to, 2.4 and some of 2.5, we're going to be doing these probably back to back. We're dividing polynomials and zeros of polynomial functions. So let's just recall divide using long division. We have x minus 2, and we want to divide that. We'll set it up like this. X squared plus 3x minus 10 divided by x minus 2. Alright, this is a binomial into a trinomial. So first of all, this is two terms. So I look at these first two terms, and I want to match this term to this one. So x times what gives me x squared? I need another x. Good. So we put it over here, and it's kind of like we multiply it, we FOIL it back in a sense. X times x is x squared, and then we would say x times negative 2 is a negative 2x. And then in division, just like we've always done, what's our next step? Subtract. But when we subtract, we got to subtract this part and this part, because technically it's like subtracting the whole thing, which if you distribute it, you'd have to subtract out the sign. So you want to make sure you change the signs of both of them in our subtract step. Alright, then add down. This term cancels. If that first term doesn't cancel, then what you chose right here, you made a mistake. That's a good cue to start over, okay? Now add down, and we would get 5x. This is two terms, and this is only one, so what do we usually do? We drop the next term. Now, we have two terms. This times what would give me this? We need a 5, good. So you would say, and it's a positive 5, so I put plus 5. Now we want to like multiply it back. 5 times x is 5x. Then we say 5 times negative 2, negative 10, and then our subtraction step is subtract. So changes the sign. That goes away, and that actually goes away, so our answer is going to be x plus 5. Okay, you might not remember that so well, so let's go ahead and do another one. When we look at this, it's in a different format, but first of all, we want to make sure our terms are in order, in descending order. So I'm going to say 6x to the third minus x squared minus 5x plus 4. And I want to divide that by 3x minus 2. Okay, we have two terms, so we want to consider it going into the first two terms, and our goal is to get this times what would give me this. Well, 3 times what would give me a 6? A 2, but then if I have one x and I need to get to 3 x's, how many more do I need? 2, good. So that determines where we start. Now once we have this, we multiply back. So we would say 2 times 3 is 6. X squared times x is x to the third. And then I want to come back here and say 2 times negative 2 is negative 4 x squared. Now remember, our subtraction step is to change both. If the first term doesn't cancel out, then you know you made a mistake in choosing this top part. Okay, now we add down, and that gives us 3x squared. This was two terms, this is only one, so we know we need to drop the next term to continue. And now we start over. This first term times what will give us this term? We just need an x. Good. So, and it's just a positive x, so say plus x. Now let's multiply it back. X times 3x is 3x squared. X times negative 2, negative 2x, and then we're going to subtract the next step, which means to change those signs. And we're left with negative 3x. What do we do next? Drop the 4, good. So now we're ready to say this times what will give us this first term? Negative 1, so good. I'm just put negative 1 multiply that negative 1 back, and then we change the sign, so this becomes positive, and then this one becomes negative, and we're left with a positive 2. Now let's talk about how we write that remainder. We would say our solution is this, 2x squared plus x minus 1, and since this is a positive 2, I have plus 2 over 3x minus 2. If that was a negative 2, I just would have said minus then 2, and you always put it back. If there's any portion that's a remainder, you always put it over this term right here. So that's your recall on your long division of polynomials. Okay, the next one we're going to look at is divide using synthetic division. Okay, and the first thing, you can only use this method is if the divisor is in the form of x minus c. And what that means is, I want you to notice there's a known 1 in front of that x. So this one, this is called that would be good for synthetic division. But what about this one? No, not so much. To make 3x minus 2 to have a 1x right there, basically I would have to divide by 3. Divide by 3, but that means I would have to divide that by 3, that by 3, that by 3, that by 3, and you could see 4 divided by 3 is a fraction already. Minus 5/3, so it would give us a ton of fractions to do division with. So we would be like, that's probably not the best thing to do. So when you have synthetic division, it's important, let me move this out the way. It's important that we make sure we're using the form x minus c. We want that to be a 1, then we're good to go with synthetic division. If not, it's probably going to make it a lot more difficult than it will be helpful. So, alright, we're in the right form, and we're going to say this is in descending order, x squared, 14x, 48. That's very important that you write it in descending order, and if they have any terms missing, you put a 0 as a placeholder. Then we say, what's the coefficient of the first term? 1. What's the coefficient of the next term? 14. 48. Write the coefficients of the term, and then over here, we're going to have negative 8. When it's in this format of x plus 8, we put a negative 8 over here, the opposite sign. Why do you think that? What happens if I set this equal to 0? What's x equal? Negative 8. So we are going to interchange back from this format to this format to be able to understand that. So synthetic division, put them in order, line them up, bring your negative 8 in the box. Here's the step. Drop the first term. Always drop the first term. Multiply right here. Negative 8 times 1. Add down. 14 plus a negative 8 is 6. Then you would start over. Multiply. Negative 48. Add down. The last box is always your remainder box. Okay, the last box is always your remainder box. Now, if this is an x to the second degree and I divided 1x out of it, then this starts with just 1x. 1 degree less, and we're going to see this in just a minute. So this is x squared, so my answer starts with x to the first since I divided 1x out of it. So this would just be x plus 6. And when you see the next example, and you start to see it, it'll start to make more sense. Alright, let's see another one. One of the most important parts is to make sure, and I'm going to write this out very long way this first time. There's no x to the third power. No x to the second power plus 0x plus 625. If you need to do this, you make sure you have zeros as placeholders for any missing terms. So for synthetic division, it's very important to be in descending order, and zeros are represented for placeholders for any missing term. Then I would write, what's the coefficient of x to the fourth? 1. Coefficient of x to the third, of x to the second, of x to the first power, of my constant. Because it's in this parenthesis format, what is this number going to be? Positive 5. Good. Now, we're ready to start. Always drop the first. Then we multiply, add down, multiply, add down, multiply, add down until we're done. All right, so here we go. We're going to start. 5 times 1 is 5. Add down. Now start over. 5 times 5 is 25. Add down. Start over. 5 times 25 is 125. Add down. 0 plus 125 is just 125. Start over. 5 times 125, 625. Add down and we get 1250. Now this is our remainder. So we would say if this is a 4th degree polynomial and we divide 1x out of it, the answer is going to start with what? A 3rd degree. Good. So then I would just say, oh, x to the 3rd, then x to the 2nd, x to the 1st. You just keep going until you run out of terms. So my answer is 1x to the 3rd plus 5x squared plus 25x plus 125 plus 1250 over x minus 5. Alright, real quick. What if I had an x to the 8th polynomial? What would my first answer, the answer of my first term start with? X to the 7th. Good. If it was an x to the 3rd, my answer is going to start with x squared, and you would just keep going until you run out of terms. And that makes sense because we're dividing 1x out of it. Got it?